That means we do not have a proof as to why this is here, although there is a theory behind it, but we do not know why this happens. Okay, it is very similar to gravitation, because there are the gravitation force is exactly this, but exchange this with m1 m2 is masses of the two objects, and of course k is a proportionality constant. In that case it is capital G, or the universal gravitational constant. So this is what Coulomb's law is. Now how did Coulomb figure this out, especially when we did not even know how to measure charges? Very interesting story, and very simple too. In simple ways, what he did was, because he could not measure charge, because if some sphere, a metal object, if it has a charge q, I do not know what that value of q is, because I cannot measure it with anything, right? So that's why it is so ingenious, and it's a very simple tactic. What he did was he took a metal sphere, and he took an identical metal sphere which was uncharged. Now if this has q and I put both of these spheres together, one is uncharged, one is charged, what's going to happen is both of these spheres will now have q by 2 charges on them, right? Because the charge q distributes itself equally on both the spheres. Similarly, I bring in another sphere and I put it together. Now I will have q by 4 charge on both the spheres that I put together, right? So what's happening in this process is, now I do not need a exact measure of q. What I do know is the ratio between the charges on the spheres, and through that, through having different pairs, so if I have q by 2 and q by 4 paired together, and now I try to figure out the force between them through a torsional balance, which is a separate unit, which is a separate tool to check the force between two objects, I will be able to check the variation in the forces in all the different cases, right? So q by 2 with q by 4, q by 4 with q by 4, q by 2 with q by 2, and so on. So I will figure out the relation between the different charges through that, and that is exactly what Coulomb did. He essentially figured out this ratio, and through this ratio he was able to give us this observation and this relation, right? Now here here by this, till now we do not know what charge is, right? So Coulomb law is very fascinating in this sense, because now I can use this Coulomb law to define a unit of charge, and unit of charge here is defined as Coulomb itself, right? We've named the unit as Coulomb itself, right? So now if I know this value and this force and k and all of these, the distance, now I can find the q as well. So that is the idea behind this, that through the charges, through the Coulomb law rather, I am able to figure out the q, the charge itself, right? So I do not need to know the charge in the beginning in most cases. So in this way, what I will do is, so another way of writing Coulomb law is 1 upon 4 pi epsilon into q1 q2 upon r square. So we replace k, which is the proportionality constant, with another form of writing it. This is still a constant value, just that we are writing it in a different form, which is 1 upon 4 pi epsilon. This form comes in from something called Gauss law, which I will be covering in another video, and so that we are using that form over here, right? The reason for this is because this is a lot more acceptable and a lot more useful going forward. That's why we use epsilon, where epsilon is permittivity of free space. For permittivity of free space. That's what this is, right? So this is how, this is what Coulomb's law is and how we work it out. Now, of course, this is a force, so we also need to figure out between two charges what is the direction of the force, and how do we figure that out? How do we make sure that the direction is correct? So between two charges, suppose one is Q1, other is Q2, and this is my, because I'll be taking vectors, so this is my zero vector or point of origin. From this for this you need a primer on vectors, so do have a look on our channel, because I will be putting that up pretty soon. So Q1 is the magnitude of the charge and R1 is the vector, the position vector of Q1. Now, between these two, the force, if I am trying to find the force on Q2 by Q1, the force direction will be this way because they will repel each other. So, force on Q2 by Q1, this is how we are denoting it. Force on Q2 by Q1 is equal to K Q1 Q2 upon R square. But what is this R? This R is this distance. This is R, which is equal to R2 minus R1. This is what this R is. This is also a vector, of course, right? And the vector direction is this way. And I will also write R cap because that is the direction of this force, this way. But remember, this is the force on Q2 by Q1. Now, if I take the opposite, which is the force on Q1 by Q2, that is on Q1 by Q2 will be equals to, the magnitude will remain the same, but the direction will be opposite. Because the direction will be opposite, so I will have to write minus R cap. Minus R cap, because in this case the R cap will be this direction, right? So I am writing minus R cap in comparison to this, not over here. So this is how I will get the force. That means this Coulomb's law follows Newton's third law, right? So that makes it the culmination of different theories together makes it so much more, makes both the theories much more powerful, because it shows the relevance and the correctness of the Coulomb's law as well as Newton's third law, right? So this is the idea behind Coulomb's law between two different charges. Similarly, I can now find, using the same form of vector law, I can just figure it out for all the different system of charges as well. It can be 3 charges, it can be 4 charges. The simple thing is I just have to do vector addition of all of them. So that's what Coulomb's law is all about. It's a very simple concept but a very important and profound one. So I hope you enjoyed this video and understood it clearly. Thanks for watching today's video, and I hope you understood Coulomb's law really well, and I would love to know your feedback and any questions that you might have in the comments below. Do subscribe and like this channel so that you know when we are putting out new content, and if you have any topics that you want us to shoot, please let us know so that we will put out our videos on those.